And this is the last question on the paper. A little bit more of a problem-solving type question, a little bit trickier than the other questions. So let's have a dive through it. As always, try it yourself, see what you think, and then hopefully this will shed some light if you're struggling. So the first bit, given that h of x is this, write down the values of a and b. So really all that question's saying is, I've moved this function, this graph, to here. So what could a and b be? So remember when you've got your, I hate when it does that there. When you've got your functions, so if you've got f, x plus a plus b, anything next to the x affects the x. Anything out with that bracket affects the b. So for example, if there was a negative 2 in front of that, I'd be saying that, x is moved over by a, and my y's will have been times by 2 and added b. Okay, so anything inside the bracket affects your x values, anything outside affects the y's. And the only other little nuance is that inside the bracket you do the opposite. Okay, so outside the bracket it's just as it is. So that says plus 2, we've gone up 2. Take away 2, we're taking away 2. If there's like 3 in front of this, we're timesing by 3. But in here we do the opposite. So if I had, f of 2x, I would half my x values. If I had f of, x take away 3, I'm adding on 3. Okay, so you do the opposite to that one. So let's have a little look at what we've got. Oh no, I thought I'd do. Right, hates doing the rubber. It takes ages to come off it for some reason. So let's have a look at our points then. So whenever I do this, I always say, okay, well, what's my original x and y? My original there, well, I know I've got a 2 and a 3, because I know I've got this turning point here. And that turning point has now become 7 and 6. So usually we have to work out the last point, but this time they've told us it. Okay, so how did I get from 2 to 7? Well, I've added on 5. Okay, how did I get to 3 to 6? Well, I've added on 3. So you would think then that that's f x plus 5 plus 3, and you'd be half right, because like I said, you need to do the opposite in here. So that is actually going to be, I'm going to take away all of that, I knew that, that's going to be take away 5 plus 3. Okay. So outside the bracket, you just do to the y's exactly as is. Inside here, you do the opposite. So I'm adding on 5, which means this has to be a takeaway 5. Pardon me. So that's us shifting our graph. Now, the next one, look at this. Not many marks for this, but there's a bit of thinking involved here, a bit of thinking. So there's not a huge amount of heavy maths, but there's a bit of problem solving going on. So it is known this, determine the value of this. Okay, well, what does this mean? Let's look at it. So if I integrate f of x between 3 and 1 with respect to x, I'm going to get an answer of 4. Okay, now remember, if you integrate between 3 and 1, and f of x is this function here, what it's saying is the area enclosed between the x-axis and the function is equal to 4. Yeah. So determine the value of 8 to 6 h of x. Okay, well there's 8 and 6, that's fine. And if I was to integrate between those 2 points, it would be the same again. It would give me that bit, and it would give me this bit down here as well. Now they've been quite helpful and drawn this little line out for you, because these 2 bits are going to be the same. That's going to be 4, but the problem is we don't know, see along here, I don't know this area in here, because that would also pop up when I integrate, because it would go from the 8 all the way up to it meets the axis. So I know the width of it is 2, I know that bit's 2, but what would the height be though? That's quite tricky. What would the height be? Well, we know that we moved our graph over, we moved it over 5, we also know we moved it up 3. So if we take that line as being the old axes, yeah, and we've moved it up 3, that means that this has to be 3 as well, doesn't it? Because I've moved the axis, which would be along here, I've moved that all up 3. So I've generated this little rectangle of 2 times 3. So in that case, I would say, well, the area is going to be 4 plus 2 times 3. So my area is going to be 10 units squared. So a wee bit of thinking involved there. They tried to help you out with this little line, So yeah, little bit of thinking, not the easiest question I've said. And very last one, sorry about all the weird colours. Given that f-1 is 6, state h-8. Okay, so what does that mean? Okay, so if I differentiate f at point 1, the gradient is going to be 6, because f dash is all the green, isn't it? So where have we got? Where's 1 on that? Okay, there's 1 there. So that's saying if I differentiate this function f of x, I'll get f dash x. And if I substitute in the point 1, I'm going to work out the gradient of that line there. Okay. So let's tell me the gradient of that line there is 6. Makes sense actually, it's quite a steep line, isn't it? So what's the value of h dash 8? Let's go over here, there's h dash, there's 8. So it's saying what would the gradient be at that point? So that point there is the same as this point over here. Because the whole graph's just been moved, isn't it? There's that value of 6 there. So it's saying, well, what's the gradient here? Well, the whole thing's symmetrical about the turning point. So the gradient over there is going to be -6. Exact same value, but negative. So I would just say -6. So for that one, quite a bit of deep knowledge, I'd say. Not a lot of marks, sadly, but not a lot of working either. But you really have to know your stuff, I think, to get your head around what's going on. And that's why I really like this question, because it really makes you think about, what are the, what's the English, what's the meaning behind the calculations that you're doing. When you look at this one, that should be quite straightforward moving it. But then this one, what does that even mean? And it's this area here, so I'm comparing this area with this. I think that's a really, really good question. And then this one's making you think about, well, wait a minute, what does it mean when you differentiate? Well, you're working out the gradient of a point. So actually, a really, really excellent question. Maybe some people would have just bang, 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 got the marks, but other people might have sat and really struggled with the meaning of all this. So I hope that's helped unravel it a little bit as to what you're calculating. And I think this also highlights the benefits of a good sketch as well. Annotate away, draw away, and just kind of take your time and see what comes to your mind. But integrating area below the curve to the axis, differentiating is the gradient of that tangent to the line, and it'll be symmetrical about the turning point. Okay, so I hope that's helpful. Not a bad little paper. Yeah, I hope that was good.